we discussed about the structures, and today we have to discuss a new point, that is file handling. First of all, why there is a requirement for file handling, and then we will see how we can handle the files. Basically, coming to the topic, if you see this figure, in this figure, you can see that there is a RAM, a hard disk. Wait a moment. Yeah. So here you can see we have RAM, and on the right hand side, you are able to see that there is a hard disk. Correct? Whenever we write a program, for example, if you have written a program like this, int a is equal to 5, and then b is equal to 6, c is equal to 7, something like this, and you use these values of a, b, c in the program. So, how, first of all, we all know that how these variables are created. All these variables are created in this program P1. P1 is given a space in RAM, and in P1, a space is created for all the three variables which you have written in the program. Also, in the same space, a space is provided for the instructions. Whatever instructions you are giving, if you are using if statement here, you are using for statement here. So all these statements need to be converted to machine level language so that your computer can understand it. Okay. So when you have this, all these things, so these things are also written over here in the RAM. And all these things are converted to machine level language for execution. But as you know that we discussed earlier something about the scope of a variable. So scopes, yes. Yeah. Is there any doubt? Okay. So if you remember, we talked about the scope of the variable. The scopes were, first was the local and second was the global. This meant that if you have defined any variable within some bracket, it will be working within this bracket. As soon as this bracket is closed, this variable is deleted from the RAM. Is the voice clearly visible, audible to all of you?
Yes, ma'am.
Is the voice clearly audible?
Yes, ma'am.
Madam, voice is clear,
Voice
but
audible.
Yes, ma'am.
Yes,
The voice is clear, but the screen is not visible.
Is it visible now?
No, ma'am.
Yes, ma'am.
Still
screen
not
is
visible?
visible,
Okay.
madam.
Screen is visible?
Yes, ma'am.
No,
I will
ma'am.
share it
Yes,
again.
ma'am.
Wait. I will share it. Now is it visible?
Ma'am.
Okay. So can we continue?
No, ma'am. Not yet, ma'am. It's written.
Not
No,
visible
madam.
yet,
Your
ma'am.
screen is not visible.
Okay, wait.
Yes, ma'am. Now it's visible.
Is it visible to all?
Yes, ma'am. It is visible.
Okay. Yes, ma'am. So can we continue now?
Yes, ma'am.
Yes.
Okay. Okay. So, if you remember that earlier when we wrote a number of programs, we declared a number of variables named A, B, C, or something like marks or grades or according to the requirement of the program. So, whenever we declare a variable, we discussed about the scope of that variable. Okay. And we discussed about the local scope and the global scope. In the case of local scope, if you remember that that variable is alive between the brackets only. So it is initiated within this bracket, and as soon as the bracket is closed or ended, there itself that variable is also dead. We can say that variable doesn't exist. So what happens in terms of memory if we talk about? In terms of memory, for example, if I declare a variable within this curly bracket, wait, I will shift the network. Give me a moment. Okay, now I think there should not be a problem. So, if you remember that we declared a number of variables, so whenever, for example, I am taking this curly bracket and here I am writing int a is equal to 5 within this curly bracket, and I made some manipulation and here I close. So, when I write this int a is equal to 5, same moment this a was created. This thing is created in program P1, right? And as soon as this curly bracket is closed, what will happen? This A will be deleted from here. So it is created when you are writing int A is equal to 5, but as soon as this curly bracket closes, it is deleted from the RAM. So it means what? All these variables, whenever you are creating the variables, all these variables are alive only during the execution of the program. As soon as the program ends, all these are deleted from the RAM. But many times, for example, if you are talking about the mark sheet of a student, your air ticket, or maybe your railway ticket, in all these information you want to retain. You don't want to get it deleted once the execution have been done. Once your railway ticket is done, you got the printout. After that, whether you want IRCTC to delete it, no, we don't want it to be deleted. So we want that thing to be stored somewhere permanently till the time we delete from our side. So for that thing, we require file handling. So basically, whatever is there in the RAM for P1, once the execution is done, this thing will be deleted from here. So you want this not to be deleted. You want this to be retained over somewhere in the hard disk. So there should be some process by which you can shift it to hard disk. It is not going directly to the hard disk on its own. We have some methods by which we have to shift it to the hard disk. Similarly, when something is written over there in the hard disk, for example, this file is there in the hard disk. Some variables are there, say A, B, C variables are there with some values, 5, say 6, say 7. I want this to be brought back to RAM. So in that case, some method should be there to get this value in the RAM also. So there are different methods for doing this. task. And this part is known as file handling in the case of C programming. Okay, how this is done. So how to do it? This is very important. Say we are having, this is your RAM and this is your in the hard disk you are having a file. This file is say having a name file dot f1.txt as it is drawn over here. The same thing I am drawing on the left hand side also. Okay, so you are having one file named f1.txt. So first thing is whether you want to send this file to hard disk or you want to get this file from the hard disk, there are some well defined procedure. Okay, first thing should be clear to you. Second thing is, for bringing this file, bringing means nobody is going and collecting a sheet of paper and going and give it to RAM. It is not like that. In the case of computers, you all know that thing. How it will be done? Basically, you will be creating a copy of the same file in the RAM. Okay, so if you many times you might have seen that there is some application from a student to maybe your faculty advisor to maybe your deans or maybe your associate deans and all those people. So what you do, you have to write an application for something, for getting a permission from the dean or director office or anywhere. So what you do, you have a fixed template written by your friend. So what you do, you ask your friend, you just send it to me. So you edit that copy, write your name and all those things, and you send it to the concerned person. Okay. So in that case, what you are doing, basically you are having the template where you are making the changes in the name and all, and using all those things, what you are doing, you are sending it to the concern. Right. So for that thing, basically you are making a copy of the original file. Right. So when you are creating a copy of the original file, after that only you are able to edit it. Same way, whenever you want to do some changes in this f1.txt, what you will do, you will create a file for this over here. Over here. Right? This is not the original f1.txt. This is a copy of f1.txt. Right? But we all know that in the hard disk, how you can locate a particular text. You know that's this thing that, as I explained earlier also, that we are having this type of memory addresses. We are having this sort of memory where each uh, line can be said to be one address. This is one address and it is having 8 bytes of memory space. 8 bytes can be stored in this. And we have so many pages like this. This is one single page, for example. So we have many pages like this. So basically, if we talk about, so how your data is stored, it say this is the first address where something is stored, then second address where something is stored. So they are stored in this way, say from 1001 address to 2021 address. Say all these addresses have been used. It is not a 4 bytes. Keep in mind, address is not a 4 bytes. This I have taken just to explain the concept. So for example, your data has been stored from 1001 to 2021. So what you want all these to locate this address. First of all, you have to locate this address where this file is stored, right? So first of all, what you will do, you need this address of what? Address of the first location. Okay, so address of first location in this case is say 1001. So this is address of first location. Because if you have first location, then consecutive locations can be identified where data is stored. So very important is the first location of that file. How to get that first location of the file is done by one structure which is named as file. As you can see here, it is written over here, struct file. Here you are able to see data structure. I have not written it completely. This is a structure which is having a name file, right? In this structure, there are 9 variables in all, which gives us different information about the copy of the file, not about the main file, right? A copy of this file. And in this case, this CURP is current pointer, which gives us the address of the first location. Okay. So it is giving us the address of the first location. And if you're having the address of the first location, then definitely you can work with it, right? So first thing is very important is how to bring this file from here to here. For that, there is one function which is known as fopen function. What it does, it creates a copy of the original file in the RAM. So this is a copy of the original file. So fopen function is used for that. Once you have fopen function, next you have to create a structure over here in the RAM, which will be named as file. And this one is having nine number of variables. Out of those variables, one is the CURP variable, which will indicate the address of the first location. If I am saying this is the first location, so it contains the address of the first location. CURP contains address of first location. So you have the address of first location. Now you can trace the consecutive addresses and go on either reading the text from there or writing text over there or something like that. So two things should be clear to you. Directly, you can't access the file from the hard drive. First of all, you have to send it to RAM. How to send it to RAM? For that, we have a fopen function. And once you have fopen function, then you have to get the address of the first location, which you can get using a structure file. File structure, right? And as we know that because this is CURP will have the address of the file. It is not giving the value of the first address. It is giving you the address of the file. So in that case, it cannot be read writing. If I am writing, say, FP is equal to CURP. If I am writing something like, and I am giving the name of the text, right? Then FP can't hold this value because FP is of integer type and it can only store the values. It cannot store the addresses. No. So what you need something which can hold the address of a particular location. And for that thing, we will use file star FP. Why star FP? Because this is a file pointer which holds the address. Pointers holds the address of any location. So instead of writing FP, we write star FP, which is the pointer which points to the address of this location, first location. And because who is pointing to this location, this file structure is pointing to this location. So this pointer will be of type file. As we have seen in the case of a structure, that whenever you are talking in terms of a structure and you want some value in that structure type, you have to declare a variable of that type. So here structure is file and you want a variable of type structure file, so that's why you have to write file first of all, and then you have to write the name of the variable. And in this case we don't want the value, we want the address. That's why we are using star fp instead of fp. I hope this part is clear to everybody. Is there any doubt in this case? No. So we will continue. So once you're able to understand this thing that we require something to open the file, and similarly, once you have made the changes in the file, you want to send it back to the hard drive. For that, we have a fclose function. If you see this side, it is fclose function, right? Now we will see a simple program where we are trying to write something in the file. If you see this program, here you can see we have used stdio.h, which was the earlier header file, string.h, which was the earlier header file. We have included one more stdlib.h, which is required for all these functions, right, which are used over here. Because we will be using fputc, fclose and fopen. So we require stdlib.h, right? So what this program is doing, we will consider step by step. First one is we have declared a pointer of type file. Why? Because this pointer will hold the address of the first location of your file. How it will hold? It is not holding directly. It is holding indirectly. As you can see over here in this figure, FP is this address, okay, and it points to this file. What is file? File is a structure. What this structure is doing? It is having different variables. Out of these variables, we are interested right now in this variable, which is known as CURP variable, current pointer. Always current pointer will point to the address of the file, right? So where it is pointing to the first address of the file right now, right? So it is pointing first address of the file. Once it is done, then what you are doing? You are declaring the character array. You are declaring the character array, which is hello students, right? Then we are declaring one more variable which will be required for loop. Next step is we are having fp is equal to fopen. Fopen is simply you are bringing this file f1.txt from this location to the buffer. So this file came over here. So basically, fopen, what it will do? It will take this file and it will send it to the buffer. So now you're having the file in the buffer, right? fp open, fopen, and this one is taken in write mode. I will discuss about the modes in the next class. So if you have, first of all, you will check whether this pointer exists or not. If it is not existing, then your printing file cannot open. And in that case, there is an emergency exit from this program, or you are emergency uh, closing this program. And that is why we have written exit one. But if this is not true, then in that case, what is to be done? Then in that case, you have to fetch text from this place, and you want to send this text to the defined location. So what we will do, because right now what it is doing now, see this thing. Say I have to enter all the letters. Instead of hello students, I will just take hello and I will explain. So I have to enter all the alphabets of hello, right? Say for one character, I am taking 8 bytes. Okay. So right now, file pointer is pointing this address. Say this address is 1001, 1002, 1003 because characters are to be stored. So it will require only 8 bytes, or that is one address location. So right now FP is indicating here this address, right? So directly you cannot store all the alphabets. You have to take each alphabet at a time and you have to place it at a address and then you have to change the address. For example, if this is the address, here you want to store H and then you want to change the address to this location. It means now you want FP to point to this location. Here you want to store E and then you want this address to be changed to this location and FP should hold this address now. Then you want L to be stored. Then L to be stored and then O to be stored. You want it this way, right? So how this thing will be done? For this thing, what we are doing, we are using a for loop where I is equal to 0 to I is less than the string length of this particular text, whatever you have written. And what you are doing, you are giving one alphabet at a time. To where you are sending it to FP. So it means what? Every time FP should be incremented. Who is incrementing? We have not written FP plus plus. Here we have not written FP plus plus. Then how that value is being incremented? No need of incrementing the addresses by from your side. Because definitely if you remember, we can't increment the addresses. We can, without using pointer, we can only increment the values by using the variables. So in this case, if you want to increment the address, there's no requirement because this thing will be maintained by current pointer. That's why the name is current pointer. It is not first pointer, it is current pointer. So as soon as what will happen, that for example, there are spaces like this. So as soon as H is held by this location, now file pointer will point to this location. Current pointer will point to this location. As soon as E is stored here, this current pointer moves to the next location. So this way, current pointer will do this task for you. So it is not required to increment the addresses from your side. Just what you have to use, what you have to put each character. This is file. This is for file, and it takes character by character. It takes a single character at a time. Okay. So what you will do, you will take that character from here and you will place it to the location. Okay. Then again to the next location and then again to the next location. So this way we are doing this thing. And finally, when you have written everything, you have to send it back. This block is to be sent back to the hard disk, which is done using fclose function, right? So this is how your system will work. Now we will talk about the different modes of operation in the case of fopen. You have seen the fopen function written over here. What this fopen function is saying, f1.txt, you can write w here, you can write r here, you can write a here, you can write r plus here, you can write w plus or a plus. All these are explained over here. R is for reading. When you want to read something from the txt file, simply you want to read. Okay. You don't want to make any changes in the file. You just want to read whatever is written over there. In that case, you can open any file in read mode. So in this case, only reading is possible and you won't create a file if it does not exist. You will only create a file in other cases. In this case, file is not created. Second case is if you want to write something in the file, W. Third case, you are appending something in the file. This is the third case. In this case, you can key R plus, you can do reading and writing, both are possible. In this case, reading and writing both are possible. And in this case, reading and appending both are possible. But there are few other changes. In the first case, in the read case, if f1.txt doesn't exist, it is not going to create it and it will show an error. If you want to read something from f1.txt but there is no f1.txt in existence, then your system will show an error. But in other cases, it will create a blank file even if it is not there, right? So this one will create a file if it does not exist. In the case of append, what it will do, it will add at the end. For example, if you want to write something is written. For example, Poonam is written. Now I want to add Sharma to it. I don't want this to be deleted, right? I want Sharma to be written over here. So it is to be done using A, that is append. But in the case of write, what it will do, it will delete Poonam and it will write Sharma here, right? That is the case with write file. This will delete the old data. Write will delete the old data. But in the case of append, what will happen? It will add at the end. In the case of R plus, reading and writing both are possible. It will create the file if it does not exist. It will overwrite the existing data. Again, it has the same problem as it was in the case of write. In the case of write plus also, it erases old data. And in the case of this thing, A plus, it will append. That is depending upon your requirement. For example, here what we are trying to do in this program, we are trying to read something from the file. If this text is written over here in the file and I want to read this text from the file. So the same process as we have done, this will remain the signature statement in the case of file handling. File star FP, this will remain signature. This is signature. You can treat it as signature statement, which will be required in each and every file handling program, right? Then we have to declare a character CH. This CH is required to read each character, single character from the file. The same process, you have to open it. In this time, you are opening it in read mode. You will check if the file exists or not. If it exists, then in that case, you will read the first alphabet from FP. FP is the location of the address of the first letter. What is the first letter here? It is W, right? So it will read the first character using fgetC function, and where it will go, this will go to CH simply, right? It will go to CH variable. Once this thing has been done, now what you have to do, you have to check whether after this something is written or not, or is it blank after this. For example, if some file is having only W is written over here, okay, after this nothing is written, so you need to check whether there is something next to be read or not, or is it the end of the file. So for that thing, we are using here one more function which is known as end of file function. End of file. As soon as it is, if there is nothing written over here, what will happen? This function FEOF function, it returns one when file ends. So that's why we have used a negation here, not FUF. This function should run till the point end is not reached. Okay, so what you want to do, you have taken the first character in the CH variable. So you want to display it. So you have written a printf statement to display it. Next what? So now you want to get the next alphabet. Again, you have to repeat that statement. Why? Because now FP is holding the next address. FP have changed the location and it is having the new address now. So what will happen now? Instead of W, E will be fetched from the file and it will go to CH. You will display again using the printf statement, and this process will continue till you reach the end of the file. And once you have done this thing, it is very compulsory to close the file. It means it is very compulsory to send this back to the hard drive, okay, from the RAM. Okay. So these are the programs which we had to discuss related to this thing related to file handling. Some more programs will be given as practice to you in the lab sessions related to file handling. You have to you try on those programs, and if you are having facing any problem, you can discuss. In the next class, we will talk about the Python, how it can be used, because you know the logic now. Just the thing is now how to write a Python code instead of a C code. Rest everything will be same, just the syntax are different. Python is relatively easy to write as compared to C programming. Okay, so if you have any doubt till this point, you can ask, else we will close the meeting. Okay, so in that case, we will close the meeting for today.